Last skill for this section is finding where graphs intersect. So in other words, here we're imagining we have two different functions. So some function, here's y equals f of x, and here's some function y equals g of x. And the thing we're trying to find is these 2 points where the two graphs happen to intersect. And there's a fairly easy way to do this that many of you are probably screaming in your head as I look at this, but I want to think about why for a second. And I want to think about what's special about this input where the intersection happens. And namely, what's special about this input where the intersection happens is that at this input, both functions have the same output. Likewise, the same is true here. At this point, at this input also, both functions have the same output. And so this is leading you to what you need to do, which is to equate the outputs. So to find the intersections, what we do is we just solve f of x equals g of x. Okay, and so probably a lot of you, when you first saw this and I started talking about it, were shouting in your heads, just set them equal to each other, and that's exactly right. To find where the intersections are, you just set the outputs equal to each other. All right, so to do an example of this, I'm going to pick as my functions f of x is x squared plus 6, and g of x is x plus 12. I'll again go ahead and pull up a graph for you. In the graph, the red graph is f, and the blue graph is g. And we can see that we're looking for two intersection points. So to find those intersection points, as we talked about, we're going to set these two things equal to each other. So I'm going to take x squared plus 6 equals x plus 12. And I'm going to solve this equation, which I'm going to do by moving everything over to the left. So I'm going to get x squared minus x minus 6 equals 0. And so I'm going to factor this. This will be x minus 3 times x plus 2 equals 0. And so I will find two x's. 3 and minus 2. Now, all we found here, these are the inputs of the intersection. How am I going to find the outputs? Well, to find the outputs, I need to put the inputs into these. And so the question that always comes up is, which of these do I put the inputs into, f or g? And if you remember how we got here, we should realize it doesn't matter, because it had better be the case that the input 3 gives the same output for both of these. Okay. And so I will take 3, comma, and then I will take f of 3, which is 15. So that is one of my intersection points. And f of minus 2, and that is 10. So that will give me minus 2, comma, 10. And in order to check your answer and be sure that you're right, you can see that g of 3, that's also 15, and g of minus 2, that's also 10. And so the fact that those line up tells us that we did all of our algebra right, and these are our two intersection points. Okay, so let's do one more example of this finding the intersection of the graphs. So again, I'll put up the graph corresponding to these two functions. And again, the red graph is f and the blue graph is g, and we're looking for that intersection there. We can see there's only one intersection, at least in this graph, and that intersection appears to have a positive x-coordinate and a negative y-coordinate. So we can double check our answer against that when we're done. But again, what do we have to do? We have to set these two things equal to each other. So that is, I have to take 2x plus 3 divided by x minus 4, and set this equal to 2x minus 3 divided by x plus 1. To solve this, I have to cross multiply. So that is I'm going to take 2x plus 3 times x plus 1 is equal to 2x minus 3 times x minus 4. Okay, again, remember I'm multiplying those and those. That's why it's called cross multiplying. And I now have to FOIL out this whole mess. So that'll be 2x squared plus 5x plus 3 is equal to 2x squared minus 11x plus 12. I'll move everything over here, so the 2x squareds will cancel. I'll get 16x minus 9 equals 0. 16x equals 9, so x is 9/16. So that is the x-coordinate of my intersection. Now I also need the output. And so I need to actually calculate one of these things at this x. So I won't think about it too hard. I'll just do g. 9/16. That will be 2 times 9/16 minus 3 divided by 9/16 plus 1. This will be 9/8 minus 3 divided by, and I can add these two because this is 16/16. So that is 25/16. Okay, so 9/8 minus 3, that is going to be 9/8 minus 24/8. All of this divided by 25/16. If I can continue this over here, this will be minus 15/8 divided by 25/16. And remember, to divide fractions is to multiply by the reciprocal. So this will be minus 15/8 times 16/25. And I want to point out at this point there's lots of cancellation. So I can cancel the 8 with the 16, which leaves a 2. And I can cancel the 5 out of the 15 and the 25, which will leave a 3 up here and a 5 down here. And so this is minus 3 times 2, which is 6, divided by 5. Okay. And so our answer is that this point is 9/16, comma, minus 6/5. So that's all for 1.4. 1.4 is really a lot of review of things that we have done already in terms of these algebra skills with fractions and factoring and all of these kinds of things, plus this idea of graphs and how to interpret graphs. For now, though, I'll leave you there, and we'll pick up next time when we'll do a quick review of how graphs of lines and parabolas work. But until then, have a good day.